Hi, I'm Dave Robinson, and welcome to another screencast where I'm going to be doing a predictive model on a Kaggle dataset as in preparation for Sliced. So Sliced is a really fun competition I'm a part of this summer. We're starting out tomorrow. That's June 22nd at 8:30 p.m. Eastern. I'm going to be live screencasting myself on attacking a data set I've never seen before and doing some predictive models. So please do tune in tomorrow for that. And but in the meantime, today, as part of this practice, I'm going to be analyzing a data set that I haven't done machine learning on before, which is box office prediction data set. I picked an old Kaggle data set that I thought looked fun to analyze. I actually, look at it now, I think I have analyzed this data once before on a Tidy Tuesday. I can't remember when. I might have even done a predictive model with Lasso, but I know I didn't use Tidy model. I'm pretty certain I didn't use Tidy models on it. So this is going to be a new it's going to be a new approach for me to try using tidy models to predict this box office data. So this is going to be as close to a dress rehearsal as I can mostly. So I've actually got a template I've set up for kicking off an analysis, loading up my packages and such. I'll try posting that tonight or tomorrow morning, just to be transparent about how I'm setting up my my workflow. But let's start by entering the competition. So let's see. Stand agree, and I'm going to download all, TMDB box office, etc., and I'm going to open that up. And all right, and then what we're going to be predicting today is and feel free to follow along if you search for a TMDB box office prediction. In fact, can I put let me put this in the chat real quick if you'd like to follow along and try competing against me. We certainly won't be the only ones on the leaderboard. Actually, we won't be on the leaderboard at all. This is a very old competition, but if you'd like to try predicting yourself, please do join. And what I'm going to try doing is, what we're going to take a look is, let's see, a data set from the movie database, and that includes, it's going to be fun, that's budget, genres, the homepage, the IMDb ID, original language, the title, an overview, and its popularity, presumably on IMDb. And there are 22 columns. I'm not seeing all of them, so we'll take a look at some of them more once we've got it loaded in. But we're going to try and predict its box office. And it's always worth checking what is the evaluation metric. It's going to be root mean squared log error. So RMSE, after we're doing the log of the revenue, we're going to have to exponentiate the revenue again once we pull this out. But that means it's going to be a linear model, not like a classification problem. So let's get started. So I've loaded up these packages. I'm telling it the metric set is RMSE. Like tomorrow, I'm going to spend a little less time explaining what I'm doing and a little more time. Tomorrow I'm going to spend very little time explaining what I'm doing. I am going to live screencast it, but TMDB box office prediction, load in my data, and I'm predicting revenue, and here I'm going to run this whole thing, and I should now have a five-fold training set. Here we go, as well as a test set for me to use locally and evaluate my evaluate my data. So let's see what we can explore from this data set based on we always going to start with the train, and there's lots of columns here. This is definitely stuff that I didn't see last time. Okay, so belongs to collection is a JSON column. Okay, so there is like bundles of collections in here, but let's start with some simpler ones and go with budget. So that's logarithmic, and is also going to be on a dollar scale. Here we go. So some very low budget things, mostly log normal between 100K and 100 million. And let's see, is it predictive of the box office? That is the revenue. So I can say budget revenue, and both are scale X and Y, both dollars, both log. And looks like maybe we have some, geom point. Here we go. Yeah, so it's so one interesting thing is that there's a lot of zero budget data that doesn't seem to mean all that much, because it can be across this entire range. And then there's generally a positive relationship. So there's a few useful things. I can also say filter, but we'd have to think about this zero budget when I'm working with this on a model, and I can do a filter to make it a little bit cleaner and to see, okay, there's generally kind of a linear trend between the two. Okay, and then we can look at genres, and genres is going to be interesting because the what I'm noticing here is that this is going to be a JSON column, and I'm going to do genres is map onto genres. I'm going to do library. I'm going to do library JSON like. It's got some. I'm going to do map. Have you worked with JSON columns before? The trick here is that you want to do from JSON like from JSON. Oop. And no, it doesn't care for this. I thought it would be a JSON. Let's see the if I do train genres 1 JSON like from JSON. Oh, that's odd. That it's using single quotes. Oh, that's a little I guess from JSON only uses double quotes, and the yeah. Let me try fixing that. It's got some data cleaning to do here first. Replace our single quotes with double quotes. And oh, missing also missing values too. So let's try filter not is in a genres. All right, so that one worked. But it did become a data frame, which actually is not that bad necessarily. But I can, because I can then unnest wider genres. This is not going to work. It's going to have ID duplicated. Can I say names repair? So the trick is that I need these genres to be like actually no, I don't like that approach because just to me each could have multiple genres. So the trick is, notice that it's got adventure, action. Oh, okay. Now that I see that that seems to be how it works, and let's take a quick look at this. I don't need to parse everything, so pull genres, pull 10 random ones. It looks like it's always name, an ID, and a name. And then what about collection? Because if this is what I think it is, what is it? Train belongs to collection. You know, it's got a name, it's got this. I don't need the poster, I don't need the backdrop. I just need the name and the yeah, okay. So what this is telling me is that I can actually extract it out a little bit more easily than I originally expected. What I can do, yeah, I'm guessing that the Tidy Tuesday one already did something like this, because I can't remember doing this before if I did work with this data set. But what I can do is do this. String genres is string extract all from genres. It would look like name and then a greedy, let me see, here, if I try grab, I'm going to take this on like one example of genres. So this is an example, and I need to build a function called extract JSON names. I'm going to use this a couple places. So that from a string, it's going to do string, so like for example, so it's going to do this string extract all. From S to take all the things that match this and extract JSON names and string extract all. So then extract JSON names from, pick an example. Yep, it grabs adventure, action, family. Yeah, but I only want to grab the capturing group. Can remember how do I? Oh yeah, string match all. That turns it into oh, this is oh yeah, that creates this column, and then I just need to do on yeah, on each item grab only the second, yeah, map. Here, grab the second column, which is the capturing group. So now this creates a list column of adventure, action, family, but I actually want to map CHR. I want to combine these into, let's say, a semicolon delimited list. This is going to be easier for me to parse later. So I'm to work with rather than a list column. So I'm going to do map onto each of these paste collapse is a semicolon, and oops. And now I get Action Adventure Family. Okay, so why am I doing all that? So that I can do mutate belongs to collection is extract JSON names belongs to collection. And now I have any of those collections will be in their JSON column, and then do the same thing to the genres. It's because I don't need to keep any IDs really. Most of these columns I don't need to have much. Let me see. We have well, let's look. Are there any other JSON columns that have multiple in them? Probably something like actor does. So let's see. The overview, popularity, poster path, production companies. Yeah, I can grab just out the names of those. Let's do that too. So let's in fact do mutate across each of these belongs to collections, genres, production companies. Apply this extract JSON names. That way I can easily add additional ones that I'm going to apply this to. That across is super handy. Production countries also. Production countries, spoken languages, keywords. All of these are one-to-many. This is going to be a blast. And lots of text, keywords, cast, and crew. Keywords, cast, and crew. Keywords, cast, crew. Oh, it's not, oh, I did it twice. Still didn't work. Let's see, what is it called? Keywords has a capital. That's odd. But I can roll with it. Keywords, cast, and crew, and all these now have, yeah, semicolon delimited ones. All right, so the, and revenue. Okay, hopefully nobody has semicolons in the middle of their name. I'm not going to check on that. All right, the, okay, so we have tons and tons of categorical things. That means we're going to be needing to do some, like, for some we'll be doing text parsing, for some we'll be doing semicolon parsing, but there's definitely a lot of, like, one-to-many categorical setups here. All right, so let's see then how what we're going to do is to start with in terms of RMSE. I also have I have a couple categorical things. I have original language. I have static. I have, oh wait, so let me see. Other ones that, besides budget, I've got, let's see, I've got a popularity. Don't put popularity on a dollar. And in fact, I wonder if popularity goes on a log axis. It does. Popularity, okay. Yeah, kind of like that other, kind of like budget. It was like, you know, there's a few really small values. Though here, not so much. And by the way, are there zero revenue? No, there aren't. Okay. Okay, so the makes sense we're judging by by the log mean squared error. All right, so revenue, so popularity might not have such a correlation with it. Let's look at what else we have to work with. We have original language, so we can do. I'm going to create a little function, summarize revenue. I find myself using this a lot where I do table. Oh, so take whatever table it is and summarize the average revenue is mean revenue, which is actually not really how I want to work with this. I probably want to use median revenue because I'm going to be doing mostly, and I could use geometric mean, and I will, in fact. Geom mean revenue is, and that'll be x of mean of log of revenue. I don't need to add 1. There's no zeros here. And I always have an n is n. Why do we do that? Because then I can say, let's group by original language, and arrange descending n. I like this because I can say group by original language, summarize revenue, and get back like, okay, English, French, Russian, etc. And then I can do a little FCP lump, language, summarize revenue, and we'll lump it into, let's say, the top 10. Mostly they're English, but sure, I'll still do that. And then plot immediately where I'll say mutate original language is FCP reorder original language by median revenue, and do median revenue original language geom point as size equals n. This nifty little graph we can say, okay, these scale x, I'll leave this on a continuous scale, but I'll do labels dollar right now. And let's say, yes, let's say whatever the ZH original language is, but I don't know. Definitely not very common, but it's got a higher revenue. Okay, so maybe that'll turn out to have a positive impact. But there aren't, besides that, there are not a ton of categorical variables here. I saw like, there's some we're not going to use at all, like homepage. There's some, well, does it have a homepage? That I can definitely like transform. I'm going to throw that in my little data cleaning step. That's a bit of information. While we're feature selecting, and let's see. Then we got text. With this the popularity, I'm just not going to use the poster. We got production companies. We got production countries, and yeah, release date. I'm also going to want to do release date is, what is that? MDY of release date, and turn to a date because I'm probably going to want to create things like year. As well as like, so there's both year and month that I can get out of this that might be kind of interesting. There's runtime. Let's take a quick look at runtime as its own predictor. Runtime, and let's try without a log scale, see how it looks. Yeah, there's like some short things, some long. See, I'm not seeing a trend, but geom smooth method lm. You know, there is a trend, and I wonder if I added it would be a little clear if I said scale x log 10, at least got rid of those. Here's the runtime. See, no, you know, it is plausible that some of these shorter movies are lower than the high movies. So I'm certainly going to want to include runtime in terms of relationship with revenue. Yeah, as well as including budget and such. That would be like my intro minimal plot would have budget and runtime, and then I'd start adding from there. But really, it's going to be, I think it's going to be these categorical ones. So I'm just quickly noting numeric predictors, definitely budget, also runtime, popularity, hard to see, and all log scale, all log plus 1. Those said budget budget 0 might be more like NA. That's the thing worth noting. The status. Do we have a status? I already have my little setup here for group by status. Rumored is future. There's revenue for rumored ones. I don't even understand how that works. Sure though. The there's only 4, so it's not rumored. Rumor's not going to be important. Only 4 things in that category. Okay. And then let's look at all the text ones. So I'm just going to write them down here while we go. There's categorical, multi, which are genres. Let's see. Genres, production companies, production countries, spoken languages, keywords, for some reason capitalized, cast crew. I think that's everything that's like multiple out of one. So these are like some of the things we can add as categorical predictors. And then there's text. There's actually like free text, which we can include the original title, overview, tagline, title. I don't know the difference between original title and title. I'm probably just going to go with one of them, though maybe the original. Yeah, maybe the difference is about the translation. Could be. No, I'm not sure. Overview, yeah. Did I say, what did I say? Overview, tagline, title. Yeah, I think that's it. Overview has like the plot. Yeah, this is going to be fun. Okay, all right. The one that I'm going to want to look at before I look at categorical and text is, so I think we're going to do a linear model and some numeric predictors, but first I really want our date time. So I actually really want to understand what's the role of date and time. So this kind of, the way you can do this is start with group by year. I know I turned it into a, I did not train cleaned. I'm going to do the cleaning in a separate step here, though later I'm going to mess with it a little bit more. Summarize revenue. Filter n is greater than, I don't know, pick only the ones with at least 10. Year, median revenue. This is not, oh, so it's probably adjusted for inflation because we can see that it's not really going up over time. Let's try making this instead of year. Let's do, yeah, so it's like, maybe it's changing a little bit, but it's not like the low point was 2010 for the median revenue. And maybe it is, maybe the median isn't changing, but the max is. You know, we can't say that much about this. What if I only did years that had at least 20? What if this is a little, yeah, I did hear about these years being the age of the blockbuster. I don't know, but the yeah, these probably are adjusted for inflation, which makes sense. Otherwise, you get a lot of power just out of correcting for year. So let's try, instead of looking at year, try looking at decade. This is a truncated division. Where am I? Not quite half an hour. That's good. That's good for exploratory analysis. And geome point. Oops, 10 times. Yeah. All right, so we have some distant future going on here. So something's up with that. The what if I do arrange descending release date? What's going on here? I have 2068, 2067, 2066. I bet. Oh, look at this. Rosemary Baby. That's not 2066. That's 1966. These are movies that came out in Thunderball. These are movies that came out in the 60s. Okay, so any movie that's over, that's after the year 2040 is probably, I probably want to subtract 20 years. So the, yeah, how do I subtract 20 years? That's so interesting. Can I do years? 10? Oh yeah, I can. This is fun. Years 20. Okay, what I want to do for a bit of cleaning is I would say release date is if else release date. If it's greater than 2040 or 101, hell, if it's greater than 2030, do then it's release date minus years 100. Otherwise, release date. A little bit of data cleaning. And now I'm going to try this this again. There you go. Here they go where they belong. See that years 100 time delta thing? Very handy. Okay, so this it does look like there is a trend, but it's a nonlinear one. If I included it, oh yeah, look at that. That's every 5 years. So year, like that's a year rounded. That's every 5 years. There's definitely a trend. It just is not linear. spikes, goes up, goes down, and oops, something's up with my year down here. It is there we go. All right, so so this is that there is a nonlinear trend from year, nonlinear, and what about time of year? So let's take a look at the month. Month is month of release date. I mean, is it true that one's in the summer? And I'm going to do label equals true. Is it true that movies in the summer have a higher tend to have higher revenue? Is it true that that's when the blockbusters come out? And I'll need a group equals 1. Oh yeah, look at that. Look at this. Check this out. This is all right. The median and I'll do a quick let's see. Scale y continuous labels is $, and yeah, look at this. There's a September dip. That's really important. So much so that I wonder, like, if I did instead of month, if I did week, is this also impactful? Like, is month going to be? I'm probably going to do something like a linear term. Like, yeah, wow, look at this. Group by week is week of release date, which I think will do the week within the year. I think. Let's find out. Yeah, look at that. You can kind of even see, all right, yeah, there's like 1 week within the year that's, yeah, there's like a couple spike weeks, probably like the start of summer and the start of December, that kind of thing. Yeah, I can make it, yeah, so I think this is cool, but I'm actually really interested in looking at this over time. So I'm going to do group by this, and let's look at month, and let's look at, so I'll do some effect of day of year or something like that, or week of year, but the main one that I'm going to be interested in is how does this compare to, kind of just their interaction term of year is going to be year of release date, and what I do, I broke it up by 5, and I say color equals factor year, and I say group is year. Too many, yeah, I'm going to need to change this to decade for one thing, and for another thing, filter for year is 1980. Yeah, so like 1990s were the year, wow, look at that, the median revenue in June of the 1990s just spiked up a whole bunch. Yeah, huh. And 2020 is a weird year with the pandemic, it looks like, but wow, look at that. And but 2020, nothing should be in 2020. The this data set was from 2 years ago, so it's not pandemic. That's like that should be the 1920s. Yeah, I think I messed up my so I say if it's greater than 2020, yeah, then subtract 100. I think those movies were from I can check that, but I think those movies were for different year. Yeah, the all right, so it had nothing to do with the pandemic. This data set is from several years ago. Okay, so the point is that there is an interaction term a little bit between month and year, not enormous. Maybe it's mostly just this 1 month, but yeah. Okay, so we can see some things going on here. All right, so I'm going to want a term for time within year, month, non-linear. Okay, let's get to building a linear model. Okay, so we're going to be using our and one of the first thing we're going to do is going to put all this cleaning steps into. Here we go. We're going to put the cleaning steps into a recipe. Now I'm just thinking for a second. How am I going to the problem is I just set the form. Oh, can I? Yeah, recipes. I'm remember myself. Set form. How do I set the formula of a recipe? The reason I'm asking is like add formula. I can select. I can step RM. I can whatever. But the problem is I'm not happy with this base situation because I'm going to need to pick the formula up here, and I'm going to have to work with it. I'll come back to this later, but it annoys me that I'm doing all these cleaning steps. In any case, the Yeah, so I'm going to set this up once, and this does a lot of my cleaning. I'm also going to do step rename keywords equals keywords, because I don't like that. I'm trying to do something that will apply to all the training and all the testing data at the same time. But I'm going to say, here we go, the recipe takes, right, of my training data, oops, not that one, of my training data, I'm going to be predicting revenue based on everything, but I'm going to start just one by, suppose I can't start one by one. All right, here's what I'm going to do. I'm going to move this up into, I'm not going to do it in recipe. Clean data function. Here we go. I'm just going to apply it once to all my data sets. Keywords does not exist. I just saw keywords a second ago. There it is, keywords. Oh, that's because I didn't change this. Okay, and now clean the data. Whew. All right, the data set is clean, and holdout is and the held out set is also cleaned. It's semicolon delimited everything. Okay, I just wanted that initial cleaning to happen. Now I don't need this anymore. I can do everything based on train. Nope, what I just said, that's not true. Oh, because I didn't rerun this entire block. I didn't rerun the steps that split it up. Yeah, okay, so here's my train, here's my over month, here's my by month and year, and here's my by week of the release date. Okay, and yeah, what I'm going to do is create my recipe where I'm going to say, I'm going to call it reclinear. I'm going to start it really simple with just my linear terms. So I know that budget is important. I know that runtime is at least a little important. Not sure if popularity is important, but it doesn't really hurt to add it. And I'm going to do year, and I'm going to do, I'm going to do release date. Then I'm going to do step mutate, release year. You know what? Yeah, I'll do it now. Release year is my feature engineering year of release date. And release month is, release week within the year is going to be week of release date. Data is missing no default. The oh right, yes. And step rm release date. What I have to do with this is prep and juice, so we can see here's the cleaned data we have so far, and then I can fit a model. And the way I go about doing that is do workflow, add recipe, reclinear, add model, and I'll just do a linear reg in here and do a little set engine. Use regular LM. Oh, but last thing I forgot to do is we'll do step log of, it's very important we do, actually I'm going to do that in the cleaning step because we never want to forget it. We're going to do revenue. No, I'm not going to do it here because I do some exploration. I describe what it said. Step log of revenue, and this will be skip equals true because it'll only be applied to the clean data. We'll say log the revenue, base is 2. I like base 2. We don't need an offset. And then I'll add another log of skip because this is the predictor data and we can't run it on the eventual data. We'll say runtime and popularity. Did I miss any? Yeah, those were the ones I remembered. The budget, runtime, popularity with an offset of 1 and a base of 2. So the offset meaning +1. And here now if I do reclinear, prep juice, look at the data. I've logged each of these. I've got my release year, my release week. And the other things I'm going to add here are going to be a step NS for release year and a step NS for release week. That's a linear spline where each of them is going to be degrees of freedom. is going to be deg free equals tune. I'll tune them separately. Okay, so what I'm going to do is going to tune linear spline for deg free year, deg free month, week of the week within the year, and my two terms. Okay, so the now I've got my linear model. I got my linear I call this usually lin rec. Here's my workflow, and yeah, let's set up the approach. We'll say lin tune, and this is specifically going to say lin tune. I'm just going to do lin tune, lin wf tune grid on, and a couple of things I'll say. I'll say on train fivefold metrics equals mset. Already create that. Yep, I did. And the metrics mset. The control is I created something earlier where I said grid control. This is useful for a couple approaches I'm going to use, and I would do fivefold tuning on. Oh, I'm going to choose. I like to choose my grid is crossing deg free year. Try a couple values of deg free year, 1 to 4. Deg free week is also 1. I'll make it 1 to 4. Let's see what this gets. So I'm adding a couple of spline terms to this week term and this year term and seeing what we get. So we do fivefold cross-validation. Remember, we're adding no categorical terms. Yeah, that's why I'm not doing any kind of penalties. There are not really a lot of degrees of freedom going on here. And then do auto plot on this. Let's see. I did set, yeah, it should be doing multiple cores. And yeah, it's useful to add. Yeah, here we go. Auto plot. Boom. Now one thing I see is, okay, adding degrees of, oh wow, this RMSE, something's up with this RMSE. I'm doing something wrong. Is it not doing a log on the eventual data? Okay. Yeah, I'm gonna put this in the cleaning steps, because yeah, revenue log to revenue. I'm just going to put that in here, and I'll have to remember to exponentiate it later. It's not in the holdout set. Yeah. All right, and the oh right, the training set. Here we go. All right, I don't need this anymore. Try this one more time. So what this is supposed to do is say, like, okay, as we change degrees of freedom on year and on week, how does the RMSE change? We can mostly ignore this. I think it's predicting on a log scale and then comparing it on a real scale, and that's not doing any good for anybody. Oh, that's what happened. I did a step log. That's no good. I need a step exponentiate as a post-processing step. I don't have that. I don't think I can do that. Disregard this this next piece. Okay, the key here is that we need 2 degrees of freedom for year, but it looks like not really more. And every degree of freedom for week, though, is kind of helping. So I'm going to do 1 or 2 for year and do 1 to 8. And let's find out how deep this rabbit hole goes and can we keep getting the RMSE down. By the way, this is a good time to go to the leaderboard and say, what is a good RMSE? Okay, so there have been, this is it's not competitive when you don't win for being at the top, but it still gives us like a sense, like, you know, where would we fall? So we want to be in like 1, 2 kind of range to be in a typical area. So certainly doing like 3.5 would not land us very well here. It would land us in well under 1,000. That's all right. We just got started. And yep, it's 845. The yeah. So let's auto plot. here we go. We want like degrees of freedom. 6 might be the best. It's like 2 degrees of freedom for year, and maybe 6. You know, yeah, sure. Let's say 6 degrees of freedom for year. Pardon me, for week. So we can finalize that. Normally I'd keep this code, but I'm just going to keep editing in. That's kind of the way we go fast with this. Is we say 2 for year. I'm not going to be. Maybe I'll be conservative. Do 4 for week. I don't like to over. I'm going to be adding penalties later, so I'm not worried about it. All right, 6 for week, and yeah, let's start adding a couple other terms. So we added numeric predictors and date time. The next key is going to be doing categorical, and for that we can start just by adding 1 and say this is where we're going to do tokenize on genres, where we'll say token equals regex and options list sep pattern equals semicolon. That way we're going to split these up and do genres. See, we've split them up into tokens now. But after splitting them into tokens, I'm generally going to need to say, okay, step tokenize, step token filter genres only keep the common ones. Max tokens is let's say, I don't know, 50. But let's actually talk for a second about that limit. So what we're going to want to ask is what is the effect of genres? So I can use separate rows on genres, and then count genres, sort equals true, and say here's our most common genres, but I don't actually want to count. I want to group by genre, summarize revenue, and ask, okay, the median oh, this is on a, it's now on a log scale. You know what I'm going to do? I'm going to be silly. I'm going to say 2 to the power of. This way I can keep my, that's why the geomean is so funny. Alright, so this way I can keep this fun function going and do these explorations. And there's 23, so I'm going to want to say, well, I'm going to try all of them. And soon we're going to be writing up a new function for working with these, but genres, geom point. So there is kind of this gap. We can say, okay, there's missing values, yeah, so having no genre is bad. Having documentary is bad for your revenue. Being foreign film is bad. Wow, all of these are so like seemingly TV and movie. I don't know. The same category. Let's check that real quick. If I do filter genres, string detect genres, TV, pull pull genres, TV, movie. Oh, okay. The problem was that I separate rows and I didn't actually tell it. Where's separate row? I didn't tell it sep equals a semicolon. TV, movie, much better. There's only one of them, which sounds like it's the Doctor Who movie. But the yeah, then I'm actually curious, like if I throw in a geom text label equals n, what do these look like? And vjust and we make size and be its own thing. I just want to show how many there are in each. vjust1, hjust1, there it is. And now it's like, okay, there's only one of these, and not very many that are missing. Yeah, you know, we can do a filter for like 20 on this, and but even then, like, even the fact that the NAs are kind of useful is like, okay, that's, guess I don't want to, well, the NA is not a token though, is it? Well, it's yeah, I still find them interesting. I don't really want to throw in a filter, but I'm gonna throw in like 22, which will throw in all but one, I suppose. Does token filter allow a minimum percentage? Hold on. Let's take a look at this. min times and max, min times, yeah, there's max tokens or, okay, min times, all right, there it is, equals 5. Why do I like that? Because now I can prep and juice it, and I've got, oh, max features was set to 100. That's fine. Oh, and then after doing the token filter, I do step TF genres. And now, whoop, I've got a column for each of them. TF genres Western and thriller and science fiction, romance and horror and music. So the so now I've got one hot encoding of this, and it can actually fit in something like a linear model. This is going to be, I think, pretty impactful. So let's try it again just right away. And yeah, let's. Nope, I'm not going to tune it anymore. But I am going to add a instead of linear reg, I'm going to add a. No, I'm going to do linear reg with glmnet. And I'm going to do penalty is tune, and I'll do penalty is yeah. So the trick is that I can actually do a whole bunch of penalties, except I can't. Probably because I'm missing. Let's see what I did. Missing data. There's always a good thing to know. Oh, max feature set to that was just a warning. That's not the problem. NA. All right. What missing data do I have? If I do this filter, not complete cases dot is a good way to find any runtime NA. All right, so I'll do a quick step what is it called? Impute. Mean impute is a good one on runtime. Make it the average. That's a good one. Let's see how it does once I do that. Oh, it's now step impute mean. That's good to know. Let's also see how to do on my. Fun thing is that, ooh, look at this. Regularization helped it a little bit. Okay, so it added a little bit of value to relative to my last one, but not a ton. So the but now I do want. See this. The dip means that I do want some regularization. So the okay, so that's genres. Let's add a couple more. Let's do. Oh, I forgot about categorical original language. So there's I'm gonna put these on like levels. Like here's the numeric ones, here's the date one, here's the categorical one, which is original language. And original language, I'm gonna want to do step other original language. Step other. So say if you're less than 1%, just get an other category. Yeah, that warning. I know about the warning. Oh heck, I'll just do max tokens is 20. Just get rid of that. All right, so I got my original language, and I wonder when I do that sort, what is the count original language? Yeah, add just a couple. We have a couple languages there. All right, and but I'm also going to do. So I've got genres, but I'm also going to throw in production. Actually, yeah, let me throw in one more while I'm doing this. Production companies. Production countries, and let's see what we get. Something might have had an NA. Well, let's see. Let's see what I got. NA is okay. What happens when I prep this and I do filter not? Oh, silly me. I didn't, there's something important, which is for these categorical ones, I believe that I have to do step dummy all the remaining nominal predictors. It's after I do the text, very important. Yeah, I think it doesn't like my my factor predictor. It wants it to become a dummy variable, like these zeros and ones. Fun fact about it is that tomorrow I'm going to be screencasting my live process here. And ooh, yeah, look at this. This regularization would be overfitting a lot, but the regularization gets down to still 3.3. Not really cracking that. Not getting past that 3.3 with a linear model, which maybe we'll get better when we get XGBoost and other things. But let's see. Yeah, I should also do step token filter on production companies and production countries. Max tokens is, I don't know, keep 50 of each. Actually, no, instead of max tokens, I'll do min times is 20. Oh, what was I doing? Oh yeah, that was supposed to be the other. Wait, no. I just didn't. Oh, that's what happened. I did not tokenize production companies and production countries. Now this had one filter. This gets the other. That's what happened with this overfitting. Is production companies, production countries. I wasn't splitting it by semicolons. Yeah, the model actually got a little bit better when I did it, right? Just a little bit, like 3.2 something. Yeah, and then, so what else do we have that's categorical? Spoken languages, cast, crew, keywords. Oh, stupid me, silly me. I totally forgot. I had turned them all in dummy variables. That's a huge nightmare. What I need is genres, production companies, production countries, spoken languages, cast, crew, keywords, and I wish I had an all tokens function. That'd be a nice addition here. And then genres I treat specially because I kind of want to keep those ones that only popped up 5 times. That probably doesn't actually help us much. But spoken languages, cast, crew, keywords. So I tokenized them. I'm going to create this. I'm going to check this out once. Any missing data? Nope. But wait. No input is determined. These messages are not a big deal. I wish that it would listen them in times and understand the max features thing. That I don't want that. Okay, only include people that appear at least 20 times, and yeah, otherwise be kind of pretty wide here. Okay, and I'm gonna run this through. Yeah, there's a all right. So we're getting better, but we're not really on the board yet. But I am really interested in this. I am interested in this model. So let's take a quick look at it. Oh yeah, these are not problems. Dot extracts. Trying to grab one of these models. The challenge is grabbing one of them. That's yeah, actually grabbing one of these models is kind of of an adventure. But I can take it. I can actually take that back. I can fit it. Oh, I'm gonna add the text first. Yeah, I'm gonna actually add the text real quickly. Okay, so so what else do I have in here? I have overview, tagline, title. So those I'm gonna tokenize the natural language. Step tokenize overview, tag view, title. Overview, tagline, title, and this one's going to be more by words, and then step token filter overview, tagline, title. I don't know, I'll do min. I can tune this, but I'll do step. I'll move some stop words from overview, tagline, title. I'll do a token filter, and then a step TF of these three. Kind of run them through the whole gamut again. Oh, right, I need to do lots and lots of terms thrown all into this linear model. What failed? Let's see. If I juiced this, what do I get? Oh, that's a confusing. This error happens. When does this error happen? Let's see. If I just had review tagline title. If I just had title, I'm going to experiment with this a little bit. It does not like my attempt to tokenize title. What would, is it called title? It is. If I move the stop words any good? Something about the stop words. Oh well, something's broken about the stop words. Huh. Or is it the mid times mixed with the stop words? We're trying to debug on the fly. Something about the combination of min. Huh. All right. Stop words, token filter, title, overview, and tagline. I like checking that it works once, and then how big is this data set? How many features? 507 features. Woof, that'll get you up in the morning. We can mess with a lot of these like filters, but yeah. So the reason I'm doing all this is I want to say, okay, what if I took this lin wf, finalize workflow, select best lin tune, fit on train. Now I'm going to do a little more tuning on things like max tokens, but actually I'll do that now. I'll do that first. Okay, so the stuff I might be interested in is like here genres are simple because there aren't a lot of genres, but I might want to add here, yeah, the min times tune, and I'm going to leave in this token filter is just 100 of each word, whatever. But this min times, maybe it's worth tuning, and we try something where we say min times is going to be 3. What if we do every time there's at least 10 words, every time there's 30 words, every time there's 30 appearances, I don't know, 50 appearances or 100. I just wanted to see like what happens if we change these up. So this is where I'm trying out this, because I have all these kind of like production companies, production countries, spoken languages, and setting different minimums. And I'm wondering like, is that minimum actually helpful in this model? So I'm trying to have 4 values. If 10 is really good, I might even bring it down to 3 or something like that. That error is not a problem. So just gotta give it a palette cleanser. Oops, why does min times, crossing min times. Why am I why is oh wait, is min times not a tunable parameter? Well, Maybe not. And if so, I'm going to try instead doing max tokens tune. Trying some different values. I like tuning by the minimum rather than max tokens because it's applied to each of these, and the max tokens for each of them probably should be different based on the cardinality. But I think it's at least it's the way to really. I should be moving on to XG Boost, and yeah, in my second half hour. So that's the kind of thing I usually want to take a look at. Here we go. That's a little more like it. Okay, if I do like 100 tokens, see, it gets like a. See, it's not even as good as the one I had a second ago, where I just had min times is 10, is it? It's not even breaking. Yeah, I'm just gonna do min times on this one. I'm gonna do what I have min times 20. What else can I tune here? I can tune the year and a little bit more. As for z-axis, I didn't use glimpse to check out the data. I used view, and I always spent a little time like looking across it. Oh no, I was wrong. I thought that I was beating 3.1, but I was doing something. Oh, max times. Oops, min times. That's a big difference. Max times versus min times. Big difference. Yeah, so this is the best model I've had so far. Okay, so I'm going to use this model for a second. I think it's going to be kind of reasonable, even if there's probably a few more tweaks I could make. It's getting, oh, and I neglected, I'm going to throw in has homepage real quick. Let's see. Remember, I added that one early on. I said, like, throw in does it have a homepage or not, that kind of thing. Yeah. So what I'll do is I'll say, take this whole workflow, fit it, and then let's work with it. Let's do here we go. Let's load this in and say what are some of the coefficients. Now these are numeric coefficients, so they can't be interpreted. The rest are going to be generally term frequencies, so they can be more interpreted. I still might want to scale them. No, I'm not going to scale them. I'm not going to scale them right now, but the next step will be to scale them, gets us a different kind of interpretation. So what I can do is I can say, all right, so this is at our best penalty and everything. The if I say top, so I say top n 30 absolute value of estimate. Estimate term geom call mutate term is FCT reorder term by estimate, and do a filter term is not equal to intercept. You just want to take a look at the at what is positive, what is negative. And what this is showing is like some impact, but it's, yeah, let me scale them real, I do want to scale them, so like, yeah, I'm going to scale them real quick. So let's do, here we go, step scale, all numeric predictors. I'll do step normalize, which doesn't really make a difference, but it'll center them and scale. It'll center them and scale them. So standard deviation 1 means 0. So the Lasso does this for you, so it's not going to make the model any better, but it is going to make this this fitted one a little more interpretable in terms of understanding what the most important terms are. So here it's like, okay, popularity and budget, remember on a log scale, really important. Has homepage turns out to be cool. It turns out to be fairly moderately important. And then a lot of like things, the TF is always a term frequency. So it's like, does it contain this word, or technically how many times it contain this word? If I throw this in 100, so it's like independent fill, 100 is too many. independent film on one side, and popularity budget and adventure and Universal Pictures and Paramount Pictures and all these things. I can really parse this apart quite a bit. I'm not going to do much more. I just think that actually, yeah, there's too much because I do want to get to the other models. But I just want to like take a quick look at, okay, here are some of the terms that are important. Yeah, I'm gonna go ahead to forests and XGBoost. Forest, I like to do a forest first because a forest shows me, let's see, these are tokenization steps. I may need to redo them, but I'm going to start just with a few linear terms on a forest. It should show me how many trees I need, and then the XGBoost is kind of on top of that. And here, I'm going to do it as, I'm going to grab all my cleaning and decide what I need and what I don't need. And I can bring some things back in later. I don't need these. And I'm going to drop, for a minute, I'm going to drop all of the tokenization. Okay, I don't need to log anymore. Drop everything that involves tokens. And I'm going to leave the dummy. And I'm going to keep these 2 years and everything and do, yeah, I'll leave an original language. Popularity has homepage we saw was kind of nice. I have somewhere here I'm missing a parenthesis. I'm missing, oh, yeah, there it is. Okay, and I'm going to call this RFRec. I'm going to say RF workflow is workflow, add recipe RFRec, add model, rand forest, mtry is tune, trees is tune, set engine, ranger. I've started doing this in line just because it's so many more lines of code. But now I'm going to take the same approach to tune grid. But I'm going to tune grid on the mtry is, let's say, 2 to 5. How many columns do I have in if I prep and bake this? A bunch. I really want to. Yeah, I'm going to have fewer languages. You know what? I'm going to drop language for a bit. I think that the RFs don't do as well when they're categorical, especially with rare levels. So I'm going to drop those and say for a sec, RF work, RFWF, the mtry and trees is 100 or 300, let's say. Here we go, mtry. Right. So trying out a couple of these. Later, yeah, what I like about it, let's see. So one thing we've seen is that the more, it's actually worse, higher RMSE, the more predictors I'm using, which is kind of a surprise to me. Among budget, runtime, popularity, has homepage, release date. That I don't see that a lot. Just for kicks, I'm going to throw in an extra. I don't think this is the problem, but I'm going to try doing it to mtry1, which doesn't make a mtry1 really would surprise me. It already is kind of competing with the best linear model we had. This is making me wonder if, like, yeah, it's making me wonder a bit. Why, yeah, more parameters, maybe, I mean, maybe some of them, yeah, really seems like that means there aren't interaction terms going on here. That's not the kind of thing I'm accustomed to being that much of a difference. Okay, yeah, so at least you do need two. Oh, wait, you do need two, not one, but not more. Okay, so M try two, that's good to know. And then, yeah, having more trees was a little bit better. All right, so that's like a little bit of a start with random forests. What would I throw in? I'd throw in genres next, I think. Well, I could throw in a lot as long as I add some harsh filters. So what if I do this? What if I do, actually no, here's what I'm gonna, yeah, here's what I'm gonna do. I'm gonna throw all these in. Comment, where am I? Right, thanks, yeah. I'm gonna throw all these in, which normally would make it enormous. And then I'm going to say step NZV, which is non-zero variance. All predictors. So then if I take RF rec and prep and juice, right, I need to uncomment these two lines. Genres doesn't exist. Let's see, where did I go? Where did I go wrong? I had genres here. I have genre. Oh, there it is. So NZV, yeah, what NZV does is remove the low variance ones. So generally ones that are mostly zero. And if I change free cut to like is 0.95 to 5. What if I say 90 to 10? It's like 9 to 1. So then I remove any that I move even more. So now I don't have a lot of terms in here. And yeah, I'm going to leave it at 95 to 5, the default. But the key is this removes any that don't have like at least a bunch of like ones in them. So it kind of applies that like othering across all of them. And I can give that a quick shot and let's see. So the best version we had with just numeric and what was it? Numeric and country was about 3.12. Sorry, and release date was 3.12. What happens if we add this? Okay, later I'm going to tune it, but I'm going to just do 300. Actually, I'll do. No, I take that back. I do want this, but I want. Yeah, okay. So I'm adding a couple terms to this. I can tune freak cut. Yeah, the Generally, I found adding categorical variables to like these kind of rare variables to a random forest doesn't do all that well. I usually want some kind of dimensionality reduction or some kind of feature selection. So here, well, what I see here is, okay, you're going to need more breaks, which makes a little bit of sense. Seek 2 to 10 by 2. And let me try just doing trees 200 by 12 even. Soon I should get to XGBoost because XGBoost does tend to win here. But I like getting a sense of here of how might I winnow down the set of features. Usually I might just use XGBoost on like all the big stuff, and then use then combine it with a linear model. That kind of stuff tends to work well. Okay, so here it's like 10 with a best. That's still not really competing all that well here. So let's try some. Let me jump ahead to XGBoost a second because I'm really curious. XGRec. I can grab all this stuff back later. But we have. Oh yeah, I'm going to drop all these. And you have just this set. Well, even the NZV doesn't. matter. It's so nice to see the data set every once in a while. Okay, and yeah, what I'm going to do then is do an XG version where we say XG rec and rand and boost tree with mtry tune and trees is tune and learn rate is tune, set engine XG boost. Okay, all right. So one thing I love about XG boost, it keeps all the trees, so I can easily say trees from 100 to 12 to 1000 by 100, and we say learn rate. I often start with 0.01, but I'm also going to start with 0.03. See how that those two do, and try. That said, we saw 2 was the best, so I'm going to try 1 to 4. 1 is usually not going to be the best, so I'm going to do 2 to 4. And heck, let's do 1200. Okay, and yeah, what I was saying here is that I can actually do like I don't need to tune this so carefully because I can actually make a graph of here's how it's learning over time. Over time, I mean as the trees continue, and see when do we get diminishing returns. Yeah, yeah, so this so far is just with this set. I may want to do dimensionality reduction on the remainder of them, on genre and everything else, or some kind of feature selection could be handy. But we're just starting with this set. Oh. All right. So the one thing I see is, yeah, we dipped very quickly. I'm actually going to, so much so that I'm going to not do that in the future. But if I do XG tune, so hard to even see. I'm just going to do XG tune collect metrics. Right, the filter trees greater than 300. Or you know what I'll do? What am I doing? I'll do auto tune coord Cartesian y lim is 3 to 4. All right, so still not quite leveling off at like. Oh, so one thing I'm seeing is these. In this case, I only needed like 500 trees. 2 predictors was doing best. Kind of similar to what we saw from the It's pretty similar to what we saw from the random forest. Okay, let's add in a little bit more data. Let's actually bring in the whole recipe. Leaving the 95. The everything must be at least 5%. And boost tree. And what was it saying in terms of learning rate? It's like, well, 01, yeah, this 03 overfit way too quickly. You can start with 01 and then maybe 0.03 later, but let's start with just learning rate 0.01. When I added these in, I really needed more, so I'll do seek 2 to 14 by 2. See, notice I'm still keeping all this tokenization kind of stuff. Oops, I neglected to put this one back in. Trouble is here, I think we're losing all the really exciting ones. We're losing the all the ones that all these rare things like independent or stuff like that. I think that's where we're going to see the real benefit. Okay, so the one thing is, yeah, more trees were better here. They at least like leveled off. More predictors were better. Still not beating 3. Let me try like 98 to 2, and try. Let's see. I think I don't need this many. I think I might need more like. Start with a couple. Yeah, doing a couple finicky things. Three to 15 by 3. 3 to 18 by 3. So I'm trying out is like searching for some better parameters. I don't like, for some reason, I like controlling them myself a little bit more than trusting like tune grid or tune bays, particularly tune bit bays with them, or doing isomorphs adjusted simulated annealing for hyperparameter selection, hyperparameter tuning. I always just, especially with things like this, where the trees parameter is all about like you can really see it level off. You just want to aim for where does it stop. Leveling off, I think you can get it a little bit more easily. But yeah, I wonder if I combine. Yeah, I feel like if I combine some PCA on some dimensionality reduction on all the terms, then I might get to a better spot. That might be what's next for me, because I do think like the more categories I add, it's going to be a little. It's gonna kind of add a lot of categories here. This is saying if something's not 2%, like for the binary ones, this will say it must not be at most, so at least 2%. Yes, not like less than 2%. So this is too low a learning rate, and even here you're still going down by 700. Once you're at 700, so let's do to 1,000. This learning rate might be too slow for me today, what I'm aiming for. And it seems like you're still gaining from more, but not by a lot. Let me do 99 to 1. Let me do 1,500. Let me do 21, or 4 to 20 by 4. I'm just trying to kind of messing with like, what's the best I can squeeze out of this set of tokenization. And well, first of all, when I do at least 1%, how high dimensional is this? That's my first question. I juice it, and 285. My goodness, that's a lot of things to select from. So much so I'm going to do it even more aggressively. And I could change the tree depth too. Not sure I will in this case. I'm going to try it out like deeper trees. I think I should. No, I changed my mind. I'm not going to go any deeper than 1,000 trees. I'm not going to go any farther than 1,000 trees. Otherwise, I'm spending a lot of time running. I'm not gaining a lot out of. Yeah, I'm going to try dimensionality reduction and XGBoost. See, we're beating our old models by a little, but not really beating random forest by much. And I haven't cracked this like 3 RMLSE yet. So I wonder if I do XGReg. In fairness, I did this in 2 hours, and the people on the scoreboard probably presumably took longer. But I still would like to do better than I'm doing right now. Here we go. See, it's leveling off really quickly, and like yeah, I'm not seeing 20, 25, not a big difference. Yeah, I see it level off. Okay, so like even 25 with. Yeah, we're not really seeing, like, I'm not seeing a lot of benefit from just adding more terms here. Nope, it's actually pretty similar to what the original random forest was. Okay, then, and I could blend the two, that and linear model, and I will be doing that for sure. But let's try, let's try a PCA recipe. I know this is so long, and I need to shorten things, but original language, let me see, leave it in original language this time. What if I did step PCA starts with TF, num comp. Well, actually, let me find out first. Let me look at this. Here we go. Let's look at this once. Prep juice. Let's actually do some PCA on this. So the and dim. Keep sticking with the 285. Why than that, it's going to get really tough to PCA, and at least without doing it sparsely. And then if I do xg, oh yeah, I want to say remove revenue. Oh, select starts with TF as matrix. This is on the full data, but it'll let us at least get a sense of like, actually let me do step normalize starts with TF first, that way that I can actually like already have this normalized. And now I can do SVD on the TF mat. Trying to look for, is there, here we are there a couple of principal components that really like, well, the first 3 are important, and then we go to 16. Okay, so I could do 16, I could do 4. I'm going to start with, I'm going to start with 16, and let's just see if we get any, or actually I'll start with both. And what I'm going to find out is, here we go, I'm going to have all these NZV removal, and then I'm going to do step PCA starts with TF oh, and num comp equals 2. I'm going to call this xgrec PCA. I'm going to do xg PCA, we're actually going to do PCA rec. And I'm going to add another tune parameter. Oh, let me see, I'm going to do, yeah, these are all right. 0.01 is all right. And here I'm going to go back doing 2, 4, 6, just 600. Because the key is I'm going to do num comp is either 4 or 16. First I want to check that this step is just so big that it's too slow to do PCA on. Finalize. Num comp is 4. Just want to see if like is it going to crash, if it's going to like be really slow. Nah, it's not too bad. PC1, PC2. Okay, so I'm going to try this num comp. Oh, See, I'm going to try a couple of, I'm going to try it like once. Why did I do 4? Stop that. 1, 2, 3 was the other point. And then 1, 2, 3, 4, 5. I don't know, 6, sure. I want to just get a sense, does adding principal components help at all to this, does adding principal components to my original set which is all these this like revenue, budget, etc. Does adding principal components help? Of all my term frequency ones, which are all of these. So yeah, if I had more time, I really would explore what some of these what some of these principal components are. Let's see how this looks. If I'm happy with this, I'll spend the remaining time doing some fun visualization, because you do get some points for visualization, and I want to like in the competition, I want to practice. Yeah, like what would good visualizations of this look like? But first, I do want to get like to see can I beat this random forest on these 5 terms. Not by much, if I can. Seeing that, like, here, 6 components. See, adding components kind of just hurt it. Yeah, look at that. The adding components look like it's actually reducing the value. I'm not seeing 4, 6. Like, maybe if I had, the best seems to be 4 with very few components. And it's not doing much better. Do I need to step normalize all the PCA ones first? I thought I already did that, but I'm not 100% sure. But I want to normalize those. What happens if I don't normalize them? I'm actually really curious suddenly that if I take this matrix and I don't, oh, a dimension is 0. XGS. PCA rec. Final, yeah. Let me just set this up. Nah, let me never, I don't necessarily need to. I just was kind of thinking like, okay, what if I do 1, PCA, 2, 3, 4, instead of adding more and more? Actually, that's a little bit limited. And if I do, so what would this look like if I took XGPCA rec, prep, finalize? Prep juice, the, I still have all my language ones, which now that I think of it, I can do. Would using PC earlier without doing the tokenization filtering lead to a single outcome? I'm not too worried about the tokenization filtering. That kind of just removes like the rare, so the rare. I do need to do the tokenization because otherwise, I'm just keeping I'm pulling out the original language. So that this way, let's see. So that way, language is is combined into that giant one. 1, 2, 3, 4. If I did, yeah, so it's just these and then the 4 terms. Okay, if I do try this, I'll try this one more time, 2 to 8. Try a couple more trees, just in case something's going on here. Now, it could be that that's the lower principal components that are meaningful, but not sure I'd bet on it. There's actually, yeah, there's a couple more things I want to try. Here, let me list quickly the things I want to. Here's what I'm going to do. I'm going to do an XGBoost. I'm going to create my model so I can upload something because I like to make sure I have something uploaded that's not like right at the end. Particularly what I'm going to do is do a stack model. So do, let's see, stacks add. I find that if I have too many tune parameters, it ends up getting really slow. So what I do is I do filter parameters select best this xg. But I'm probably going to suit it to the regular one, not the xg one. Not the principal component one. What I would say is I want to combine the linear model with the XG model, and I bet it will outcompete both of them because you probably will be getting some yeah, see, like more components. Oh wait, no. More components is worse at basically every level of this. Yeah, so I don't think this is I don't think PCA on text is going to be very promising here. Okay. So I'm going to start with just this version, and I'll set it pretty high. Let me see. Yeah, now this was actually tuned. Was this pre PCA? Yeah. Take a quick look. That maxed out at what? Oh, XG tune maxed out at 3.09, rather minimum out. And if I just tried tune it, or should I just try a high? Well, let's see. If I try 95 to 5, and yeah. Actually, what if I set slightly lower learning rate, 2,000, fewer terms. Trying to find the best version of this like relatively small one I can do. Or what if I removed everything that was, I'm gonna remove quickly. Let me see. This throws in some extra. I don't like it. I don't like all these terms. I'm just gonna leave in. You know what? I'm just gonna leave in genres because I know they're so impactful. Maybe there's some relationships there, and I'm gonna kill everything else. I'll leave in a little bit of language. I bet these genres aren't helpful in the XG boost. Let's find out. I'm trying to remove everything except genres, and then I bet it's going to be relatively few. Try is 2 to 4. Generally, a lower learning rate and more trees is generally better. Oh, I added genres and I need more trees than this. More tries than this, that is. I wouldn't be surprised if the effective genre turns out to be mostly linear, and then I can just combine the XG boost with the linear model. So much waiting in this game. This thing's not a thing yet. So he's still improving a little bit. I'd go past 1,000 on this. He's still, it's still pretty good, but 5 versus 6, not a big difference. So I could just do kind of like, with genres included, I would do like 3 to 8, and I'd go a little farther on 500 and 4 to 8. This is with a lower learning rate. We're going to get a slightly better RMSE. And then I'll try removing genre. See if we can beat that with XGBoost. Just wondering, like maybe it's a waste of even looking at these. Oops. Yeah, it's really leveling off there. But 8 is still sort of the best. I don't know, they kind of, I'll get it even a little better there. Okay, and what is the best version of that? Oops. That was fun. The best version of that was 3.05. Okay, sure. And 3.05 versus, let's try version 2 with no genre. And trees are more like 2 to 4. And whichever one of these is better, I go with that as the XG version. Oh, this should be XG 2. Keeping 2 in case I want to keep the original. I don't need to retune it. And then in the meantime, I'm going to say, oh, see, XG. It's similar, but the genres help just a little bit. Okay, so I'll use the original. So I'll say, yep, just a little bit, the genres help. So I'm gonna keep 4 to 8 and leave in genres and all those. So I have my original code. And then I'm gonna do XG best is select is XG tune, select filter, parameters, select best. This is still not for me the part of the workflow that I'm the best at. And the that's right. Oh, and lin best. Is this the right auto plot? Yep, that's a good version. And then stacks, add candidates, lin best. I like to only add the best from each, otherwise it makes it a lot faster. And the, oh boy. What just happened? Well, let's hope this doesn't happen tomorrow. Let's, What's going on here? I wonder if these two are different training sets somehow. They shouldn't have. Okay. I'm gonna try this step first. That worked. And let me just see this for a second. This is XG best. And predictions looks right. Okay. Each of them is 450. And predictions, each of them has 450. These look pretty good. No, then why is this doing this? 450 times 5, is that, yeah, that'll be these 5. So something is up between, when I try, oh, there it is. 2 of the models failed. On LinBest they failed? That's so interesting. All right, let's take a look at LinTune. Try rerunning this one more time. Remember this model, this whole linear one? About 15 minutes since because I started 3 minutes after the hour. This worked. Oh, look at that. 2 of them failed. Only 18 was Only 18 were available. I wonder if these warnings somehow cause 2 of these folds to just up and fail. That's strange. Oh, wait, no, wait, hold on. Yeah, here it is. Length of the names not equal to array extent. Okay, something happened on this one. I don't have time to fully explore it, so I'm going to try. Let's see if what if I just removed one of the. Yeah, 2 of these models failed was what happened. Still failed. What happens if I remove all my 3 of my text ones? No, I want to be debugging a model at the last minute. Nope, 2 of these failed. Okay, then I'm going to need to test this out for a second. Okay, what I'll do is I'll take a look at train v5-fold. Splits 1, nope, 2 was where it failed. It failed on 2 and 3. Training on this one, and take this and run my linrec prep on this. And yeah, there's where the fail is. And I don't know why. Yeah, I really don't know why. I wish, let me see, the names, prep, let's see if I said, is there some missing data in here that, no, of course there's missing data, but, all right, I'll need to just keep dropping things out, see what happens. Oh, hey, I think that helped. Okay, so it was one of those. Considering just how much worse does that make the model? Realistically, I might have to rerun that. Realistically, I might just have to go with that workflow. Yeah, it's a lot worse. Let me try. Let me see if I can put back. What can I put back? If I drop the keyword, step rm contains keywords. Nope, doesn't like it. Oh, right, of course. Step rm contains keywords, not step rm not contains keywords. Still doesn't work. Oh, now everything's always failing, all the time, always. Oh, because I left this line commented out. I don't know what is failing here. See that? It wasn't keywords. This is not my favorite part of this process. Could just take the XG model, but I really want to do an ensemble up. Let me see. Nope, still failing. Minus production companies, minus countries. Trying out just randomly removing some of these because I do not know where that error popped up. Still failing. All right, I'm going to have to go with commenting them all out, which I had a second ago. Yep, here we go. Oh well. Actually, can I leave just genres? Does genres work? I like the genres. Well, this is right. Well, the problem is at least genres. What if I just kept a different one? Maybe it's the min times that's causing problems. Can I just add one? Can I just add cast? I do not like this approach. I don't like this approach to debugging. I don't like anything about this. All right. Oh well. Still keep the other ones, but something's going on. Yeah. All right, and all right, it's still not that bad a model. Okay, and now I go back down to lim best. Here we go. Nope, still failing. I thought that I removed. Oh, I still have genres, right? Yeah. Oh. No. This one worked. Okay. Oof. Okay, and zero. Okay, lim best. That looks good. This looks good. Don't know if it's saying zero, but I'll do blend predictions. All the models. See, yeah, it's the oddest thing. I'm really lost here. Huh. It keeps happening where it's like, let me see. This is not, well, at least I'm getting all my mistakes out today before tomorrow's big day. Really wanted this to, so why does it say zero? I added this, and it's one. This, and it's zero. If I add all of them, what do I get? What just happened? Why does this best one work and then this one removes it? Stacks has been so frustrating to me. Yeah, I don't know what's happening here. All right, here's what I'm gonna do. I wouldn't make it if this were the actual competition, I guess, but the what I'm gonna do is do a quick thing where I say unnest predictions. I'm gonna do it myself. Where we say, all right, my predictions and my yeah. And I've got both of them, and I've got the actual revenue. So I would say, now let's predict revenue explained by, oh, and right, we'll do select dot row dot pred revenue and model spread model pred. And now I've got a prediction for everyone, and I'll do a linear of linear plus XGBoost explains revenue. So the model would be this amount plus this of XGBoost. So here's my combination. this is my linear model. And then I'll do lin best fit is going to be lin wf finalize workflow something about stacks. Every time I use this, something's just a little bit off with it. And I fit my two, and then I can do something like bind calls predict lin best fit on my holdout. And then I give them names, where I say rename see, I'm doing this job for it. This is great. This is, I like all the things that are going on here. Here I go. I have my ID and these. Oh, I can bring that in later. But and now what I'll do is I'll actually augment this with the with my combination, the model. Oops, it's new data. So now now it's transmute ID is holdout ID, and revenue is 2 to the power of dot fitted. What I did is I just did the combination myself. Okay, and this is on holdout. This is on their holdout set, but I'm going to do it on test first. Let's see. Test. Let's see. I can find out my accuracy on the test set, my 750 that I held out originally, and do RMSE. Of log 2 of Fred. I'm going to re-log it versus actual revenue. Log 3.19. It's not that far from what that's kind of similar to what I had, but I'll do it on the holdout. Right, CSV. And do a quick late submission. I think it's going to be not great. Yeah, I guess it's going to be somewhere above 3, which puts me in not a great place. Oops. Look at me go. Revenue. I wonder where I got an NA here. Let's see where I got an NA. One NA on the linear in one row. I have a feeling that was like, I have a vague guess. Well, I can actually just kind of fix it where I can say replace NA linear equals, I don't know, whatever the average of linear is going to be, maybe about 20. Whatever, it's only one observation. So one good bit of news is that while I was doing worse in this set, it actually seemed to do a lot better in the holdout. I wonder if that's something to do with the zeros, but yeah, so the score was, in the end, it was 2.1. So I just about made it from 2 hours when I started working, and but yeah, I really shouldn't push it this much. I really need to take before tomorrow. I'm going to take another look at the uh, yeah. I'm not going to be on the leaderboard because it's a late submission, but let's see, where would it have ended up? Around the middle? Yeah, around the middle, around 600 something. The I'm curious how it would have done compared to just the linear model, the XG model by itself. I'm not gonna do that right now. I'm feeling like taking a break. All right, so what do we do today? The we did this one took more data cleaning than most of the ones we've tried so far. We had to do some like extracting of JSON names. We did the boilerplate for bringing in the data and bringing it apart. We did lots of EDA where we did things like look at popularity by revenue, runtime by revenue, budget by revenue, which is probably the strongest predictor, language by revenue, and the and then we and yeah, then we took a look at difference over year and over month, so seeing those summer blockbusters, then a little bit by year and month. Oop, that was group is. Yeah, what did I do wrong here? Oops, something's up. Oh well, the this one worked. This worked, but the revenue is still logged and something went wrong. Yeah, something's strange in the neighborhood. And oh, that's right, I kept on train. This is that old version. So yes, then we did the then we said, okay, we can look at a little combination by date range and year, but really, yeah, we definitely want a non-linear term based on when you are in the year, maybe with a spline, but ideally with some kind of tree. And then we took a look at the genres and the revenue that you make in each of those each of these genres, and saw, okay, that's going to be one of the most impactful. But then we took a look at the linear. We did a giant linear model. We did a smaller XGBoost model, and the we plotted a little bit about the interpretation of the. And I could have used this a little bit more to realize, oh, look at it now. I should have kept in production companies from XGBoost because so many of the positive ones of production companies, and even like, yeah, you can see like some of these positive and negative terms. I probably could have used this for a little bit more feature selection. But then I took a look at Forest and XGBoost, and I saw that Forest didn't even do that much worse than Forest was actually pretty similar to XGBoost in this case. I probably could have used the Forest if felt like it's actually in this case the cross validity was pretty similar, and that was yeah. So those are things we yeah. Oh, I said 3.12. Yeah, a little different than what I saw before, but yeah, and then we did some XGBoost. I tried to use stacks and it was failing on me, and I tried I tried doing a PCA and found it wasn't being and doing an XGBoost and it wasn't helpful. So I ditched that approach, and then yeah, and then finalized with this cook my own blend approach to combine the linear and the XGBoost models. Okay. That's it from me. And please, if you join today, please be sure to join tomorrow for the actual sliced episode. So that's going to be 8:30 p.m. Eastern on Nick Wan's Data Science Twitch channel between about tomorrow for sure. All right, then time to go get a good night's rest. Hope you had fun. I certainly did. See you tomorrow.